We are talking today about ultrasonic imaging and capturing costs from saving through sound. First of all, I show you a bit something about the science behind ultrasound leak detection, then how to find the leaks and to report them, some application examples, and of course, very important, realizing the savings in the end. How is ultrasonic happening? Gas molecules are hitting each other because of turbulence, and this causes ultrasonic noise. So it is a great tool for picking up the presence of certain kinds of defects very early in the component failure timeline. We concentrate today mostly on gaseous leak applications, means mainly compressed air leaks, but you can as well detect steam systems, vacuum leaks, and natural gases. It's very important to remember that a leak may not produce enough noise to be distinguishable from the background noise. In every production, you have kind of noise of running machines, etc. And normally when you detect leaks by noise, you have to turn off the systems. And with an ultrasound solution, you can do this during the running production. For example, very small methane leaks like are required to be detected in the upstream oil and gas industry might not be detectable with this method. Vacuum leaks are producing a turbulence into the inside of the component, which means less noise is transferred to the camera, but we have detected vacuum leaks in the past as well. For example, some weeks ago, I was in a coffee factory where they produce coffee from the bean to the final milled. When there's a leak occurring, it's hard to detect. We were able, especially during the freezing process, to detect vacuum leaks, and this has saved a lot of money because food was not contaminated in the end. We are focusing mostly on compressed air leaks today. We are able to detect them in most of the cases. Why is ultrasound so good for detecting leaks? It is way more faster than point scanning method. With the point scanning method, you are just shooting in the dark. With an ultrasonic imager, you make the sound visible on display, which makes it way more easier to locate the leak. The technique is way more easy to learn. You need just one sense. So point scanning methods, for example, you are wearing a headphone. With our solution with ultrasound and an ultrasound imager, you just need your eyes and just look on the display where the leak occurs. We have advanced analytics to separate the noise from the background noise, which allows us to work in a heavy noise environment. Some weeks ago, I made a demo in a die casting factory for aluminum where they are producing gearboxes. It was so loud there, and we were able to detect around 20 leaks in close to 45 minutes, which is impossible with a just point scanner. It's a quick solution and simple way to scan a lot of complex machinery and compressed air systems in an easy way, easy to learn, and a really good method to, in the end, to save money. What you can see here in the picture is that our device is a one-hand solution, which makes it very easy to handle. You can secure yourself with a second hand, for example. So let's continue to the applications. Compressed air systems lose around 25 to 30% of the produced air into leaks. Means increasing energy costs, compressor lifetime is reduced, and you have extra maintenance costs for extra equipment. These data you see here are from the USA Department of Energy. They indicate that compressed air systems account for 10% of all electricity and roughly 16% of all motor system energy used in US manufacturing industries. So there is a lot of potential to save money. So where to look for air leaks? Every one of these red boxes here in this presentation represents a potential leak source. And how do we document the leaks? very easily. So we went through the factory, have done our snapshots. Then we go to SI124viewer.flir.com. We log in here easily with our username and password. And this is what you see then later in the viewer. Here you see the single snapshots. All these orange and yellow markings are the typical leaks that we've found. Here we take a closer look. The maximum decibel level was 68.6 decibel. We can move the slider here, which is marked here in this circle, to make the leak a bit more visible. This was the strongest leak that was detected in this case. It was 3.3 on the bottom. On the left, you see the distance. It was 3.3 feet away. Here on top, you see again the distance, 3.3 foot away. Utilization 24 hours, 7 days, 52 weeks. You can adjust this depending on how your system is running. If you stop the compressors at some point, you can adjust it to 50 weeks or whatever. And this has then an effect, of course, of the estimated annual costs. So the second green arrow here in this picture, you see first the estimated leak size per minute, and as well the estimated annual costs. The annual costs are depending on the leak size, the distance, and the utilization time. What you can add as well, you can use tags. So for example, to specify more in this case, where was the leak located, which factory, which hall were you, or just to indicate a bit more for the maintenance guys later who do the repair. In the end, you can add comments, for example, what kind of parts are necessary, or any hint maybe about the priority. Then you can make your report. Going back, you can mark them here, just set a mark, and then you can generate a report. So it's a PDF report, which is ISO 50001 compatible. You will get a full estimation of all leak sizes that are marked for the report, and including as well a full amount of estimated leak costs. Then you can order it by date or by leak size or whatever, and then you generate a report. Yeah, so this is how a typical leak report then looks like. If you are using already Flir thermal cameras, there is a plugin for Thermal Studio. So when you are already familiar with Thermal Studio, just download the plugin, and then you can create your reports for the acoustic imaging as well. Now we see some examples of typical images that were shot during a walk through a factory. So here, for example, we have one at a connector at this 90-degree angle. It is quite far away. When the production is running, you have noise around. You would never find this very easy. So here we have a leak from a bit longer distance, a bit far away. We should get closer and locate the source. In a typical factory environment, it's possible to detect leaks 1 foot up to 430 feet. So typical industry factory environment is easy to scan. Here we have it in a box with lots of compressed air. In the end, the return on invest is really important. How do we realize the savings? Important question. Do air leaks cost money? A clear yes. Here, this is a study from Paul Studebaker from 2006, based on running 24/7. We can expect an improperly maintained compressed air system to cost the company many $10,000s of dollars every year. We can prevent that using an acoustic imager. Yeah, here's a return on invest equation from the USA Department of Energy. We've created a spreadsheet tool, which is this equation has built in. So we have the SI124 ROA calculator, which makes it easy to calculate possible saving. You can possibly avoid just buying a new compressor. So maybe no need of extra equipment, just find the leaks, and this will help you to save costs. In the end, you get a strong return on investment for compressed air leak inspection. Ultrasonic imaging makes it easy to inspect, and it's a target-rich environment for manufacturers, consultants, and contractors. In these devices, you find more information on our website, as well a data sheet. You can find the manual and a quick start guide. Just scan this QR code.
Yeah, so we do have a few questions here that came up. What is the smallest leak size that can be detected?
Smallest leak size that can be detected is about 4 milliliter per minute at 1.2 bar from around 1 foot.
Okay. So another question here: can I share images with others? Can you explain again how to transfer images that are captured in the field from the camera to the computer?
Yeah, good question. So when we take a look into this, you can download this image separately to your computer. It's a PNG file. As well, with every snapshot you take, you can download a 4-second video and as well transfer it later into a full report. So you can download separately the images or just the video, or you generate a PDF report or an Excel file with all the data that were taken.
Yeah, the second part of the question was about transferring images from the camera to this software that we're seeing here.
Yeah, you can use a USB stick, or it's possible to do it via Wi-Fi. So depending on your hardware and what is allowed due to data privacy at your company, you can use both methods. Looking back to the demos I've done in the past, it's about 50-50.
So, okay, so either using some sort of physical media, right, to get it out, USB stick, or just an automatic upload from the camera, right, to the cloud service.
Exactly. Okay. Yeah, or to the local computer by Wi-Fi works as well. Yeah.
The other question, I think you alluded to distance, but maybe just to reiterate, is how far away can you detect a leak from?
Always size matters in this case, and distance matters as well. Just the formula, as close as possible is good, but it's possible to detect from 1 foot up to 430 feet. Why this long distance? This is relevant, for example, when we are talking about the partial discharge detection. When you go to a substation, distance is for safety reasons definitely necessary. So, but in a regular industrial environment, to 40, 50, 60 feet, no problem. You will find leaks for sure when you cannot get close to it. Yeah.
Florian, I was wondering, because you use this model a lot. I know there's a few different models of the SI124. Which one is it that you used in that coffee factory story that you told us, where you found the vacuum leaks? Do you recall?
Yeah, it was the SI124 LD plus. Yes, exactly. Yeah, yeah.
That's the one I thought it was, because there are a few different models.
Yeah, yeah. So we have one device for compressed air and every gaseous applications. Then we have a model for partial discharge only, and we have a dual camera which can be used for both use cases. But when we talk about compressed air and gaseous applications, the 124 LD Plus is the device to go. Yeah. It's easy to use. One of my customers, for example, has done a trainee program. They do a trainee 3-month leak detection competition. All the trainees in the company are going as called leak detectives to find leaks in the factory, and they make kind of a competition who finds more leaks. It's a fun thing, and yeah, they share the camera, and everybody wants to beat the other one, of course.
Great.
Another question came up around the environment. It says, does the SI124 work in loud industrial environments?
Yeah, of course, of course. The camera is detecting between 2 and 65 kilohertz, which means all noise around. The camera is just ignoring this. So the camera works in a noisy environment and is just taking care of the real leak frequency, which is between 2 and 65 kilohertz.
Well, thank you guys all so much for your time today. We really appreciate your expertise. It's always great to see these groundbreaking products in use and hear from how they're being used and how they're saving money, saving manufacturers in the field every day.
Thank you for having us.
Yeah, thanks for having us, and thanks for giving the chance to show this device.
Thank you so much. If anybody attending has any questions, feel free to reach out to us at testequipmentdepot.com.